Hi viewers, welcome back to my channel. Today we are going to solve the Leetcode problem of the day. Coming to the problem statement, number of ways to paint n by 3 grid. And the status of the problem is hard. Coming to the problem complete statement, you have a grid of size n by 3 and you want to paint each cell of the grid with exactly one of the three colors, red, yellow or green, while making sure that no two adjacent cells have the same color. That is, no two cells that share the vertical or horizontal sides have the same color. Given n the number of rows of the grid, return the number of ways you can paint this grid. As the answer may grow large, the answer must be computed modulo 10 power 9 plus 7. So first of all, we have to be clear with the problem statement. Once again, I am reading the problem statement stepwise. You have a grid of size n by 3 and you want to paint each cell of the grid with exactly one of the three colors. So they will give us an array. Let's assume that the grid has an array, 2D array, where number of rows is denoting with n and number of columns is fixed, that is 3 columns. There might be 1 row, 2 rows, 3 rows and n rows. Okay, so these 3 columns or row wise, we have to fill it distinctly with the given colors, red, yellow or green. Distinct means no two adjacent colors should be same. Either it is row wise or column wise, the colors should not match. See, red, yellow, red. The adjacents are different. The adjacent colors are different. Suppose the number of rows is 2 means the color should not come like this. If the first cell is red and the bottom cell might be yellow or green, but it should not be red. Okay. Since they have given only one row, we are checking the number of possibilities of the one row here. These all are the possibilities of a single row. Don't get confused here. This is one possibility of a single row, 3 columns. This is one possibility of that given single row, 3 columns. And this is one possibility. Like that we have 1, 2, 3, 4, 12 possibilities. So number of ways of filling a single row 3 column array is 12 possibilities. So at last they mentioned is given the number of rows of the grid, return the number of ways you can paint this grid. As the answer may grow large, the answer must be computed modulo 10 power 9 plus 7. So they are asking us to do the modulo operation of the final output. Since it is the permutations, number of possibilities, there might be multiple ways to fill the colors. If there are multiple ways, the answer should be large. The answer might be large, obviously. So in order to manage the constraints, they are asking us to perform the modulo operation at last when you compute the final answer. Let us see the constraints. See, n less than or equal to 5000. So the number of rows is between 1 to 4999. So for one row we got 12 possibilities. Let's assume if number of rows is 4999, how many possibilities we might get? So in order to hold the value or the final answer, they're asking us to perform the modulo operation. Okay. Now let us go. So before jumping into the solution, you have to decide which algorithm it follows, or at least the problem statement falls under which topic in the DSA. So you can easily identify which algorithm or which concept it is falling, under which concept it is falling. See, they are asking the number of ways. See, with italic words they highlighted the number of ways you can paint this grid. Number of ways means not a single way, number of ways. So we ultimately we will hit one point. It is a dynamic programming, or the combination. Dynamic programming involves a recursion. Whenever you see the number of ways or the number of types or the number of steps, these kind of a sentence in the problem statement, first you should think about the dynamic programming, DP concepts. Okay. So in the problem statement they mentioned it as a hard problem, but it is not that much hard problem. it is a medium range problem, but I'm not sure why they mark it as a hard problem. Okay, it's a medium problem only, so don't care about these all hard, easy, simple. Sometimes a easy problem might be hard while we are solving that problem. So don't look at those statements, easy, medium, hard. It will scare you or it will make you to negotiate the problem. Try everything in your initial stage. Okay. So now let's proceed with the solution. Since I don't have the pen board, to explain in the live, I prepared the slide wise step-by-step procedure, how we can achieve the solution, how we can solve it. So I will try to provide the solution in pen board from next video onwards. As of now, we will proceed like this. So the given problem setup is, see, you can see the grid like this, where 3 columns are there and the rows is 3. Okay, let's assume n is equal to 3 and columns is equal to 3. We need the given colors is red, yellow and green. Okay, so we can fill those 3 colors in 2 ways. First type is same pattern, like A, B, A means these 2 colors are same, middle color is different. Let's assume this pattern is same. This is our custom assumption. Okay, so you can see red, yellow, red, green, red, green, yellow, green, yellow. So starting and ending colors are same and the middle color is different. This is type 1. We can name it as the same. So if we fill in the same pattern, the number of ways it will give is 6 ways. How 6 ways? See, the first grid have the 3 options, 3 into the second grid have already we used 1 color, so remaining is 2 colors. 2 into obviously the last grid have one and only one option, 1, and we need to multiply this. We need to multiply the number of possibilities. We don't have the constraints that yellow color should come at the starting grid like that. So yellow color might be first or last. So we need to multiply that. This is the permutations, not a combinations and permutations. We are not arranging it. We are seeing the possibilities. That's it. We are not arranging. Okay, arranging in row wise, color wise, not entire row wise. So we need to multiply that. So number of possibilities is equal to 6. For one row, it is 6 possibilities. Coming to the type 2. The type 2 is we are not repeating the color in a row. So every color is different. For each grid, we are giving the separate colors, distinct colors. In that way, the number of possibilities of a single row is 6 as usual. Because the first grid will get the 3 possibilities and second grid will get 2 possibilities and last one, final grid will get only 1 possibility. So in both the same pattern and distinct pattern, different pattern, the number of possibilities of colors of a single row is 6. And now we need to combine the solution. 6 plus 6 is equal to 12. Okay, so the combined number of possibilities is 12. This is when there is a single row. Okay, I think you got it. When they have given n is equal to 1 and number of columns is 3, the number of possibilities of filling a distinct color is 12. Okay, now going to the second row. What if the n value is greater than 1? If n value is greater than 1, the second row colors will depend on the first row. The second row need to check its adjacent colors along with it above row colors. Okay, it need to take care of its adjacent colors as well as the above row colors. Let's see how it will varies when coming from the second row onwards. Here, previous row, let's assume the previous row is red, yellow and red. Same pattern it is following. We need to fill the below row, means second row. So the second row will depends only on the previous row. Now we need to count how many valid rows can be placed below. Okay. Now we need to count how many valid rows can be placed below. Let's assume the combination of the second row also follows the type 1 combination. That is, let's assume for just now we assume it as a x, y, x, because first and last color is same and middle one is different. What the condition here? These two colors should not be same, r and x. This r and x should not be same, and this y and y should not be same. Also, x and y should not be same. Okay, that's what I highlighted here. See, this color should not be same. Now write the possible combinations. What are the possible combinations which satisfy the highlighted condition? If you write one by one combinations, there will be three possibilities which will satisfy the above condition. This is for the type 1, same. The first row following the same condition, and the second row also following the matching colors at first and last, and middle is different. Coming to the second possibility, in the first row we might have same colors at starting and ending, but the second row follow the distinct colors. Both three grids might have the distinct colors. In that scenario, how many number of possibilities are there for the second row based upon the first row? Let's assume the first row will have red, yellow and red. The first row is filled with red, yellow and red. For assumption, let's assume XYZ is the colors of the second row. So what are the conditions here? The red color should not match with X, yellow color should not match with Y, and red color should not match with Z. Along with that, X should not match with Y and Y should not match with Z. We need to take care of both first row and the adjacent grids of the second row. Okay. Now we have only three colors. First, take pen and paper. Note down the number of possibilities of the second row, which satisfies the non-matching condition of first row and the adjacent grids. You should practice with pen and paper. Without noting down the number of possibilities, you can't get the solution and you can't even understand it. Okay, I noted down the possibilities. You can check here. See, green, red, Y is one possibility for the second row, and yellow, green, red is the another possibility for the second row, which follows distinct colors. You can check whatever the with the different colors also, it won't satisfy. Now check, red is not matching with green, yellow is not matching with red is not matching with yellow, and the adjustments are also different. So the condition is satisfied. It is one possibility. Similarly, yellow, green, red is another possibility for the second row. So there are two possibilities which satisfies the condition for the second row. So how many cases we listed here? Same, it is one case. Same, different, it is second case. Different, same, it is third case. And different, it is fourth case. So these two cases are similar. First note down the first row. Next, write the all possibilities of the second row. You will get how many ways are there in order to fill the second row. Okay. So by following that operation, you will get to know the combination, which I drawn the table here. Let's see here. See, if you follow, same, 1 second, I will make it more formatted. Okay, the combination is first row and second row follows the same pattern. First row and second row follows the same pattern. The number of possibilities for the second row is 3. If the first row and second row follows the same and different pattern, the number of possibilities for the second row is 2. Again, if the first row follows the different pattern and second row follows the same pattern, the number of possibilities is 2. Similarly, the first row follows the different pattern and the second row follows the different pattern, the number of possibilities is 2. Okay. See, again I am saying you, I noted down every possibility here since it is a countable colors, 3 colors. Okay. And also we are recalculating it. I mean, in DP there are different concepts like tabulation, memorization, tabulation. So I'm not following the tabulation or memorization. I'm recalculating again when the same scenario is getting arrived. Okay. So the formula which we can derive is the possibility of same colors filled is same into 3. We know that the same have 3 possibilities and same different have 2 possibilities. And different, filling the different color possibility is different into same 2, different into different 2 possibilities. Okay. See, this is nothing but, in order to fill the second row, there might be 2 options. Whether the second row first and last color is same, or first, last and middle colors are different. If the second row first and last colors is same, based on the top row, we need to find the possibilities. If the top row have first and last same colors, the number of possibilities is 3. If the top row have all distinct colors, the number of possibilities is 2. That's it. Simple formula we can derive like that, based on the number of outcomes. Similarly, if the second row we are willing to fill with different colors, if the second row we are willing to fill with different colors, like first grid, second grid and third grid, we are willing to fill different colors, there might be 2 possibilities. I mean, based on the first row. If the first row is same, number of ways to fill the second row is 2. If the first row all colors are different, the number of ways to fill the second row is 2. We need to add the both possibilities, and the final output is sum of new same plus sum of new different. Okay. So this is the implementation this is in Python. So we will go the implementation in Java. Okay. See, you can see here, the only variable which dynamically changes is row, the number of rows. The number of columns are fixed. If n is equal to 1, we can directly return the response as 12, because in starting I told you the number of possibilities to fill the row is 6 in one scenario, and in different color scenario, number of possibilities is 6. Total is 12. So same and different are 6. We are going to return the same and different modulo 10 power 9 plus 7, which mentioned in the question. In case if n is greater than 1, we need to run the loop. Means row wise we need to calculate the number of possibilities. For that, we will start from 2, because for first row we already calculated the number of possible responses. So reducing one iteration, we will start from 2 and continue up to n, equal to n, not less than n, less than or equal to n. Okay. So we will execute our derived formula and assign that possibilities to the same and new different to the different, and return the number of ways which is modulated with 10 power 9 plus 7. Since the answer might be in long format, they are expecting the int, return type is int. So we are we are making it in the integer format. Okay, and then returning the response. Let's see by running this one. Yeah, that's it. The solution got submitted, and our solution is around, it beats the 93.85%. It doesn't mean don't compare your solution with others. Like this one, sometimes it will varies according to the Leetcode algorithm. Sometimes it will show 93. If I submit it again, there might be or might not be difference, but usually it is not that much accurate. You no need to bother, like my solution is not optimized when compared to others like that. First make it work and then you can optimize it. Okay. So, and take care of while returning the statement, where you need to explicitly convert the long answer to the integer. Okay. And one more thing, this is not a hard problem. If you want to give the rating for this question, it will be around 7 out of 10. It is not that much hard. It's a simple. The breakdown of the problem statement is, first find out it is which concept, whether it is dynamic programming, whether it is a recursion, whether it is array, whether it is a string, like that. Once finding out it is which concept, you need to find the algorithm, which algorithm it is. Will it follow any inbuilt algorithm? If not, You have to derive your algorithm. You have to derive your formulas. That's it. The problem will be done. So read the problem statement clearly and then proceed with the solution. Thank you.